Any questions, problems before we start? So you have the upcoming deadline for design stage 2, and for that design stage, so let me actually get to the lab page. So what we want is just a relational schema version of your ER diagram, and you can follow this example on the lab homepage. So you just need to talk about each table, what are the attributes and what are their types, and whether there are some unique attributes, whether do you allow null values for any of the attributes, and what are the primary keys and what are the foreign keys. So that's what you need to do for the upcoming stage. So that's design stage 2, and later for implementation stage 1, you are going to start creating this database file using SQLite Studio. So right now you don't need to create the database using the software. You just give a document, give a text representation of it. But later you are going to start creating the database. And then we also posted the functional requirements for the project. We actually sent it with the email, and it's also available on Moodle. And in that functional requirements document, so let me actually open it, I guess. So these are the functional requirements for the project. So for each of the topics, we have 3 different scenarios. And in implementation stage 2, you are going to choose one of these scenarios and you are going to implement it using Python. So in Python, we are going to import the database, and we are going to run some queries, get some results from the database, and we are going to interact with the user. And to do that, we are going to use graphical user interfaces. But today we are going to first start without the graphical part. We are going to see how we can use Python to import our database file, to run some queries, get some results, and also get some input from the user to interact with the database. And any of the files that we are going to use today are also posted on the lab page. So we have this lab 4 slides, and there's this Jupyter notebook file. So I guess you got the Python course before this course, but some of you may not have used a Jupyter notebook. So if the Python is not installed on your computer, I guess the easiest way or the most practical way to install it is going to be by using the Anaconda distribution. So in the slides we also have a walkthrough to how to install that. So let me actually go through those steps. So starting with this lab, we are going to use Python, but our intention is to manage our SQLite database files. So you will be creating your database file in SQLite Studio, for example. Then we are going to import it using Python. And for that, Python is required, but having Jupyter Notebook is also useful. So I'm going to show what it is if you don't know. Do you actually, if you use the Jupyter Notebook, or if you know it, can you click on yes from the Zoom? If you're not, you can click on no. So the Jupyter Notebook is okay. So that's going to be useful, but it's not that required. So you can just go with Python as well. And if Python is not installed on the computer, I suggest using the Anaconda distribution, and the slides are actually going through the steps of how to install that. We have the link on the slides and on the website as well. The version that we are going to use is called the individual edition, so that's the free version. There are some paid versions as well, but you just go to the download link there and you choose the one that's compatible with your operating system. So it's available for Windows, macOS and Linux, and in this tutorial, since my system is a Windows, I'm using that Windows version. And once it downloads, just start installing. So the steps are simple. You just agree, you just click on next. You may change the destination folder to install it, but you can go with the default version as well. In the settings, you can just go with the default version. So after the installation, it asks whether you want to bookmark some information pages. So in that step, maybe you can uncheck these two things. So we don't really need to bookmark those pages in our browser. And then here comes how to open it. So let's open it here. So it installs a couple of programs together, and the main part is called Anaconda Navigator. So if you go to the start menu and type Anaconda Navigator, you can open it from there, or it should also install some shortcuts. You can just directly find this Anaconda tree folder, and in here we have the Anaconda Navigator. And in the first initial startup, it might take a while to set the things, but this is going to be the view once you open that. So in here you can have different environments, and it installs and sets up one environment. It is called the base or the root environment during the installation process. So once you open it, you will see different applications that you might run using Python. And for example, if you need the command line version, so you just click on this command line application, and this is using Python using command line. For example, if you need to pip install something, you can just type it here. So pip is one way of installing libraries from the internet. Or for example, I can type Python to start using Python, and from the command line I can directly write some Python code and get the answers for it. And using exit I can get out of there. I can close this command line prompt. So the thing that we are going to use is called the Jupyter Notebook, because it gives us an option to write separate pieces of code, and in between we can also write some notes. So in the labs it's more useful, that's why we are using. And you might also see that being useful, because most of the time if you are working with Python, you come up with this Jupyter Notebooks files. So I'm going to launch it, and if I were to create a new environment in Anaconda, so you don't really need to, but the Jupyter Notebook might be not pre-installed. So in those cases, in some of the applications, you will see that it says install. So if it is not installed, you need to install that. So once you run this Jupyter Notebook, it has some root folder. So in mine, for example, it's in the users in the users folder, in the base user. So this folder is the root directory for this Jupyter Notebook. So I'm seeing the folders and files in that part. So Batu asks, can we write in Spider? So you can write in any part. So this is just what I'm going to be using, and if it is not installed, if Python is not installed on your computer, this is going to be how to install it or use it. But you can use any version or any distribution, and you can use the Spider as well. So in here I'm seeing the folders and files in that directory. And for example, the Jupyter Notebook files are, they have the IPYNB extension. I can just choose one of them and start working on them. But in this case, I'm going to create a new notebook file. So I'm going to click on this new button, and in here I'm going to choose Python 3. You can also create different kinds of files here. So these are using my default internet browser. So that's why I'm seeing it in Chrome. If some other browser is installed as a default browser on your computer, you will see that browser. So it is going to be the same thing exactly. And in the Jupyter Notebook, we have different cells. So we can write code into cells. So for example, this is one cell. So let me write like 3 plus 4, maybe x equals 3 plus 4. And then on the next line, I can say print x, for example. To run it, I have this run button at top. So if I click on that button, it will run this cell. If I'm outputting something, it will display that output. And it will also create a next cell if it is the last cell that I'm working on. So in here, for example, I can say like print, hey, if I run that one, it puts the output, creates a new cell. But if I'm back to the first cell, maybe I change some of the values, then I can run it again. And in this left part, it shows the number, and these numbers are in order of execution. So I first run the first cell, it was saying 1, then I run this next one, it is saying 2 now, and then back to the first one, I run it again, it says 3. And to run it, I can use Control Enter from my keyboard, so it's the hotkey, and each time I run some cell, it increments the number. So if you see like some number there, maybe when you are trying on your computer, if it is different, that might be the case. So each cell can be a code cell. So if I go through cell, I have the cell type. It can be a code cell or a markdown cell. So if I choose markdown, it is not for running the code. This is for some description. And if I say run for this description, I actually can use some markup language. I can change the color, change the font, etc., change the size of the font. And these are for giving some information for this notebook file. And in the file that we have here, there are actually some code cells and some markdown cells to give some description. So if you see such thing, those are doing that. So the slides also go through such steps. For example, if there's some code piece, I thought, okay, I was actually able to copy them, I guess, yeah. So if there's some code in the slide, I also put it as a text box. So you can, for example, copy that code, come to here, and run it and see the results. But be careful, since this is like copying it as a text, so once you copy it and paste it here, it might not keep a good form. So in here the problem is we lost one of the quotation marks here, so some symbols might not transfer that well. So looking and like writing it exactly would be a better option, I guess. So we can we know using Python we can define functions, for example, and in some other cell. So this was actually to showcase the Python, the Jupyter Notebook. So we can define the functions in some cell. So actually I didn't try to copy those. I was guessing there could be problems, but actually there are lots of problems, I guess, from copying them. But in here, for example, I can define one function in one cell. So if I run that, since this is the definition, it is not going to output anything. But in some other cell, I can call this function with different input values. For example, let's call it multiple times with different values, and if I run it, I'm going to see the results. So one thing, although the cells are independent, the running code is the same. So we have the same kernel running. So if you go to a kernel, you can interrupt that kernel, for example, stop it from running, or you can like start it again. So if I restart this kernel, I'm going to lose my variables. So if I restart and go to this cell, if I try to run, then it's going to say that my multiply is not defined, because I need to first run the cell that contains the description of my function, and then I can come here and run the function. So that's one thing to say about. So let's continue with the slides. One thing, okay, to notice, once we create the file, it gave a name to it automatically. To change the name, I need to click on this untitled part, and I can give a new name, for example, lab4 tests for this file, and it's going to rename, but I already have this file, so let me call it lab test 2, for example. Oh, sorry, I also have that file. Let's call it lab test 3 then. So that's how we rename our files. And now if I go out of this, so I can close this notebook file. In the home page, so this is the home page for Jupyter Notebook. In here I will see that, so because of this green symbol, and in here it says running, I see that this kernel is still running, it's not terminated. This was the file that I was working on. So I can choose it, I can, for example, shut down to close it from running, and I can move it to different folders, I can rename it, and the download version, the download button, since we are working in a browser environment, the interaction with our root directory is like by uploading and downloading something. So I can actually go to this root directory on my file browser, and I will see that my new file is also there. So this is the file that I just created. So I can copy it, move it to some place else, but I can also in here choose that file and download it if I don't want to like manage it to folders. So that's one way to interact. So to open it again, I'm going to just click on it, and it is going to run it in a separate window or a separate tab. And again, since this was terminated, I need to run the definitions first, for example. So to create a new database file, so that is going to be our example file, but I guess once we copy it from here, there might be some problems on this part. So I'm going to just open the one that actually contains the original version. So this is going to be just for testing using SQLite 3. So this is going to be the library that we are going to use to interact with the SQLite database. So let me insert a cell above, and I'm going to use this cell and go through one by one. So important to import it, if your Python is some version greater than 2.7, I guess, it's already included in the Python distribution. So you don't need to install any separate libraries for SQLite 3. But to test it, you can like just run that cell that says import SQLite 3. So if it doesn't give any error, it means that your Python version is fine. Otherwise, you might need to install a higher version of Python in that case. But if you installed in recent years, then it should be fine. So we are going to connect to a database file, so SQLite database file. This SQLite3.connect function creates the database file if it doesn't exist. But if it exists in the directory of this Jupyter Notebook file, then it is going to connect to that database. So that's one thing you might be careful about. So if you want to start from scratch, just here give the name of that file. For example, this is going to be the new database file. In this case, there is no new DB file in that folder. And once we connect, we are going to keep a cursor. So this is like some pointer to the connection. And through this cursor, we are going to execute queries, get some results, and interact with the user. So for example, in this database, since we just created it through Python, there are no tables. So I might want to create some new tables for this database. In that case, I'm going to execute. So this is the function that we are going to use. So we are using it with this cursor. We are going to execute some query, and any SQL query, any query that you are able to write in SQLite Studio, you can write it here. So for example, while creating the tables, we were creating the attributes, and at the last stage we were committing, and while committing in SQLite Studio, it was also showing us the query that it uses. So this is one of those queries. So I have the user table, and in here I have ID, which is the primary key, and I also have name and surname, which are all null values. Then we are inserting some data, but for insertion we are also using SQL. So these are again using the same function. So using this cursor, just execute this query, and queries are given as strings. And we can have different representation of strings in Python. For example, if I use this 3 single quotation marks, then anything until the second occurrence of these 3 quotation marks are going to be a string. So I can have multiple lines of string with this notation. If I use double quotation, then anything in between this at the same line is going to be a string, for example. If I break that line, then there is problem, right? In here, these are not a part of the string. So to execute something, it should be a whole string. And within that string, remember, we still have the rules for SQL. And in SQL language, so the thing that is in the quotation marks is going to be my SQL query. And in an SQL query, values for numbers, we are just directly writing the numbers. But for names, for example, for text values, we need to include those single quotation marks. So in here as well, I need to include those single quotation marks. And one thing to be careful is we connected to a database file. We worked on it. We might create some new data. We could update some data. Unless we commit the changes, they are not saved. So in here we are going to look at examples, what happens if we don't commit. So I'm going to comment this commit part for now to show that what happens. Then some queries could return results. So those are the selection queries, right? So for example, this is the most basic one that we could write, that is going to be executed using the same approach. But this time, since this is a selection query, it is going to return one or more results. So these results, these rows, can be iterated using a for loop. So this is going to return us a list of values, and for each of these values in that list, so I'm calling a row, I'm going to print those rows. And at the end, we are going to close that connection. So instead of saying cursor, we are using this connection at the top. So this is the main one, the connection to that database. At the end, we just say connection close. So let me run this one. So the output is, for these 4 queries to create the table and to insert new users, there is no output. The only output is through this printing. Let me run it again. So the next time I run it, it actually says that there is already this user table in the database. I did not commit changes, but while creating the tables, so for creation of the tables, it creates them directly in the database. So there is already a definition for this table. So let me get rid of that part and try to run it again. So the table is already created. I'm connecting to the same database. I'm inserting users, but I'm not committing. Therefore, if I run this multiple times, the only users are going to be these 3 users. Now I will uncomment this part. So I'm going to commit the changes. So if I run it now, the first time, it is going to save the changes to the database. And if I run it again, there's going to be a problem. So I'm trying to insert some user, and that user has ID number 1, but ID was the primary key of the user table. It is going to have duplicate values. So the ID, user's ID should be unique, but it creates duplicate values. So therefore it cannot execute this query. So let me change the IDs to some valid IDs. Then you will see that these changes are also saved into the database. So if you are testing something, for example, if you are not sure about the insertion or deletion queries, you might skip the commit part at the beginning, and then once you are sure that it works, you can include this commit part. So unless you have the commit, it is not going to insert or update the values. So this is also some other option. So let's say there is some database file, but you don't really know what are the tables. And let's say you don't have any SQL Lit Studio installed on your computer. Using this kind of notation, actually, do I have lab3db? No, so that's the problem in here. Right now, I don't have this lab3 database file in my root directory. So we are going to use this SQL database from lab number 3. So you can download it. And once you download it, to include it into the folder, I'm going to go into the home page of Jupyter Notebook, and I'm going to click on upload. So I'm going to add some new data to there. So it is going to be this lab3db file. I'm going to open it, and in here, uploading actually means just it copies it to the folder. So let me actually override it. Why I'm overriding? Because lab3db was not there, but because I'm trying to connect there, it created this empty lab3 database file. So that was the thing why I needed to override that file. So right now, if I run it, then it is going to show a summary of this database. So if you say SQLite master, so it is actually keeping some special tables. So there is no SQLite master table that I created. It automatically creates it. And if I select everything from there, if I list everything from there, I'm going to see some information about my tables. For example, this is a table, this is some other table, and it's called the user table. And it also shows the create table statement that I initially used for creating this user table. And I actually created these tables using SQLite Studio. So using SQLite Studio is a better way to create the tables because there is this graphical user interface. Otherwise, you can just also go directly and write the create table statements for each of these tables. And you will also see that indexes are created. So for each of the tables, because of their primary keys, it automatically creates these indexes. So now I'm connected to an existing database and I can run queries using the same approach. So in this next cell, for example, what I'm doing, these three parts, so I'm going to import it multiple times actually. You don't really need to import it multiple times. So remember, with our function, once you run the definition, you can call that function from any place. Once you import the library, you can use it from any cell. But if you are just going to open this file and run one of the cells to so as not to get any errors saying that I cannot find SQLite tree, etc., I'm treating these cells individually. So if we need to import something for the individual cells, I'm including it there. So that's for the sake of the examples. For example, if you just want to run one of the cells so as not to get an error. So I'm going to run it. It displays the results. And this is just a query, a simple query actually. It uses multiple tables. It makes the join operation. If you remember from last lab, we were keeping which users are partners of which companies. And I also have some where conditions saying that the credit should be higher than 400. And this is again using the same convention. We are getting a set of results, and for each of these results we are printing the rows. And since we did not make any changes, since we did not update, delete or insert, we really don't need to commit. So if you are not updating, not inserting something, you don't need to commit the changes. Only you need to do it once when you insert or delete or update something. So this is what this slides are talking about. And we are now going through another Jupyter Notebook file, and we are going to look at more detailed examples. We also have this API reference. So each of the functions that we are using are actually coming from this API. So we are using SQLite tree. So anything that we use as a function is included here. And for example, if you need help, you could check it as well. So now we are going to go through this notebook file, and it also requires this lab3 database file. These are all included on the lab page as well. So this is the file. I'm going to download it, and so this file, I'm done with it. I'm going to the home page of the Jupyter Notebook, and in here, so since you downloaded those files, you need to import them to your working directory, and I already imported lab3, right, just now, and I also need to get lab4 IPYNB. I'm going to upload it, and I can see it now here, this one. So I have multiple versions to test it out. You will have just one version of it. So once you open it, you will see that we have lots of cells. We have some descriptions as well. So let's go through these cells one by one. So in here, it's actually simple. We are importing the database. Then I'm also printing some text to give me information. So I just connected to that database. If you are not seeing anything, so for example in here you might execute this query but not get any results. That might mean that lab3 database is not in your working directory, and it creates that for you. So make sure that if you are not getting any results, this Jupyter Notebook file should be in the same level as your database file. So we are inserting a bunch of rows. Actually, we are first showing our companies. We are inserting a new company and we are showing the companies after this insertion, and we are closing without any commits. So if I run it, I will see that, okay, there are 10 companies before insertion. After insertion, there are 11 companies. But if I run this query again, that's going to be the same result all the time, because we are not committing the changes. So one thing important, if you want to save the results, the new results, you need to commit the changes. So in this other part, we are creating a new connection to this database, and this new company, Plutronics, is not there because we did not commit the changes. And in this next cell, we are actually going to commit the changes before closing. And in here, we are going to insert new companies using like different ways. So we know that using this 3 quotation, single quotation marks, we can write the string. So that's one way of writing SQL query. We can contain it in double quotations. So the whole line, or the line up to this second instance of the double quotation, is going to be a string. We can give parameters to the query. So this is something new. So in SQL Studio, we were just typing the values, but what we can do is we can write question marks in order. So in our query, in any query. So in this case, it's an insertion, but in any of the kinds, in different versions, for example, in selection, deletion, etc., we can put quotation marks, multiple quotation marks, and we can give values to replace those quotation marks with the execute function. So the first parameter of the execute function, this is a string. The second parameter should be a tuple. So we might have just one question mark, but this second parameter should be a tuple. So tuple means that it contains multiple values in parentheses, so separated with commas. But even if it is just one value, to keep it in the tuple form, we contain it in parentheses, and we need to put this comma as well. So that's how we pass parameters. So this 13, the first 13, or the first element in this tuple, which is 13, is going to actually replace the first question mark when I execute it. And I can have more than one question mark in the query. So in the string, I have multiple question marks, and they are going to be replaced by each of these tuples. I can put these tuples directly here, or I can use a variable to replace them. I can also define multiple tuples, but this time use the execute many function. So the execute many function is going to call this or execute this query, replacing each of the question marks with the corresponding tuples for each of these tuples. So I'm giving a set of tuples between these square brackets, and in each tuple I should have the same number of elements. So for example, I have 3 question marks and I need to have 3 elements in a tuple. So that's going to execute multiple times the same query with different values replacing each of these question marks. And while you are giving the attributes, you should make sure that you are giving them in the correct order. For example, in the company table, the first one is ID, then the company name, and then the monthly payment. And these should be in order, and they should have the matching type. For example, since the company name is a string, I should include it as a string in my tuple. For date as well, it is going to be using the single quotation marks. So let me run this let me run this cell. I run it, but I'm not seeing any output because it's not outputting something, but I did not get any errors. That's some good thing. If I try to run this query again, then it's going to give me an error because I'm trying to insert the same primary key. So once I run it, if I try to run it again, I get the unique constraint failed error. Now if we connect to this database and print the companies, we will see that the new companies are also there since we committed. So now we are going to use some user inputs in our query. So one way of getting user import from the command line is using the input function. So the string that I write inside the input function is displayed to the user, and then user types something, hits the enter key, and then the value that I get from this input is going to be contained in my limit variable. And in here, to show the information, I'm printing it, and these are the order of the columns. Then using this limit variable, I'm going to execute a query, and in that query what I'm doing is selecting the ID, name, surname, credit of the users, and with the condition saying that the credit should be higher than this question mark, and that question mark is going to be replaced with my limit. So for example, if I run it, it asks for a limit. So if I type some value here, for example 500, if I hit enter key, then I'm going to see the users that are satisfied with this query, with this condition. So let me also show what happens if you don't give a tuple here. So I'm going to run it again. So it says enter the limit because the input part is before running this query. For example, if I write something here, actually there was no problem. Okay, let me actually try to restart, because in my case it was given initially error. Oh, the 66 is not a good value maybe. Okay, the thing is now it says okay, we are giving three things. Okay, the problem with the first run was, I guess I just typed just one number. Okay, that was the problem, I guess. Let me run it again with just one number. With just one number there is no problem because it is just a single thing. The problem is, since we are getting the input as a string, if there are multiple numbers in that string, and if I try to give it directly here, it thinks that these separate characters are individual characters, and it thinks that I gave three things because I put three numbers, but this has only one question mark that's saying that. Let's try what happens if we say this is going to be an integer. So three numbers, and again the problem, we can only concatenate strings. So okay, that's some other problem. So let me make it string, multiple numbers. Okay, it has a problem. You cannot give anything but a tuple. You have to give a tuple. So that was something I'm trying to show, but we like went through different errors. So now it functions as we expect. So in this example, we are going to use date input. So date could be sometimes like hard to manage because you need to follow some strict form. So the year, month, and day, they should be in order. We are using this dashes in between, and it should be within the single quotations as well. So in this case, we are going to get two dates from the user. So we can get multiple inputs one by one. And what we are doing is to get the users that are born in between those two dates. So in here we actually say the date of birth should be larger than this first question mark, and it should be less than this second question mark, and those question marks are the date limits that we get. So let me run this one. Let me insert some two dates. So that's the starting, and let's put something for the ending date. And these are the users that are born in between those two dates. So we have a bunch of users that these ones are born in between those dates. So now with the date, you might need to sometimes get today's date, for example. So this cell contains examples of that. So in the project, for example, maybe you are creating a new order, you are adding some new user, and you need to use the date of today. And to do that, you can use the datetime library in Python. So there are actually multiple different ways of doing it, but one way is using the datetime library, and we get the today's dates. But today's date actually, so let me actually try to print it. And I also need to import it first. So if you look at it contains more than the date. It also contains the time, and the format could change according to the system that you are using. For example, the day and month places could change. So we need to put it into the format that SQLite uses. So this function is doing that. So it puts the year, the month, and the day separated with dash symbols, and it gives you the string. So today's date contains the string that I need to use, but it should be a tuple. So this part is converting it to a tuple. Then we are inserting this new user, and for the date of birth of this new user, we are using today's date. So if I just run this query, it inserted the user. I'm also committing, and in this next part, next cell, we are just showing all the users, and in here at the end we see that new user, and it contains today's date. And sometimes you may need to generate random dates, for example, or you may need to find the difference in between two dates. For example, maybe we are making a database for a library, and we need to calculate how many days passed since the first borrowing. So we can remember get today's date here and convert it to a string that uses the correct format. But using this datetime library, we can also define day differences. So for that, we are using the time delta function. So to time delta function, you can also give seconds. If you look at the description of the function, you can also give milliseconds, but there is no months, I guess, I'm not sure. But to this function, we are now giving 50 days to define a 50 days of difference. And we can add or subtract time deltas from datetime objects. So the other date is going to be 50 days earlier than today. And while printing, I'm putting it into a correct format. And to get the date difference in between two different dates, I can again define two datetime objects. So to create a new datetime object, I'm giving the year, month, and the day in between the parentheses. So these are the parameters to create a new date. And in here, so the difference is D2 minus D1, and we are displaying the difference in terms of days. So you can also display it in terms of seconds, etc., I guess. But in here, we are interested in the day difference. And if you want to create a random date, you can use the random library. For example, with the random integer, we are giving the beginning and the ending range. and ending numbers for that range, but I'm using for day 27 because some months could have less days, and creating and showing a random date. So when we run this cell, each time we run it, we are going to see a different random date. It shows the today's date, and 50 days earlier it was this day, and between these 2 days there are this much difference. So let's give a 10 minutes break, and we will continue at 9:30. If you have any questions, problems you might ask. Any questions or problems before we start? So these are actually easy to use. So these libraries, functions are there to make the life easier, and they are like fairly easy to use, and you can like reuse some code from these cells when you are creating or doing your project. So the date operations was in this cell, and let's look at some error messages that we might get. So there could be 3 different kinds of problems. The first, there could be a syntax error for Python. There could be a syntax error for the SQL query that we are trying to run, or there can be some condition, or let's say, for example, if the IDs are conflicting in the database, some database operations could be problematic. So you should be like able to distinguish which is which. For example, in here, the Python syntax is correct, SQL syntax is actually correct, but we are trying to use some variable or table name which does not exist in the database. So there is no table called use in the database. Therefore, when we run this is the error message. So this is it is called an operational error. It says no such table as use. So this should be the user table, for example, to list the users correctly. You can also have like syntax errors for the SQL query. For example, if I write from wrong, then it says near FRM because it's not sure what this is. There is some syntax error. It doesn't really say the exact problem. So it is a typo for the keywords. It doesn't say it like that. But up to this part, it seems okay. But in this part, near FRM, there is some syntax error. It's saying that. For example, I can also put some comma next to this star, and this time it says near from. There is some syntax error. Maybe I missed some of the attributes. I can select everything and then also select some additional attributes which is included in the star, for example. So in here we are writing the attribute name wrong. So if I run this cell, now it's going to say no such column. Okay, the user column exists, but there is no such column with the name with 2 E's. Then in here we are failing the constraint. So if I try to run, what we are doing is to insert a new company with an ID that already exists in the database. So in this case, it says integrity error. So this is not because of the syntax, it is because of the values that I'm trying to insert. This value is going to fail the unique constraint for company ID. Any questions, problems? Okay. So we can also try to insert wrong number of values. For example, we tried actually using the tuple. The tuple was problematic, but we can also write an SQL query that contains less values. For example, to insert a new company, I need 3 columns. I need the CID of the company, company name, and also the monthly payment. But in this case, the name of the company is missing. In here it says the table company has 3 columns, but we are giving 3 values. For example, if I give more, then it's again another problem. So I forgot the comma. So I need to give the exact number of the parameters. And then these parameters should be compatible. So if I try to insert a number for a string, I can do that, but whether it is meaningful for the database or not, I need to control it in the application part. So any number is also a string. So for a company's name, using a number is actually a valid thing, so that can insert. So for some columns, we were putting the not null constraint, and if there is this constraint for a table, for example, if I run this code, it's going to this time say not null constraint failed. So this is again called an integrity error. For the company's company name, it cannot be null, it says. So one other way of writing insert queries was that after the name of the table, in here we were giving the attributes or the column names, CID, company name, and we also have the monthly payments. So to see I write the columns right, let me check here. Okay, I wrote the columns right, so it is not saying these columns are missing. So for these three attributes or columns, I'm giving these three values, and I can also skip some of the columns. For example, I can skip the company name, and if I try to run it, it's again going to give the same error because I cannot leave company name empty. If I use this notation without directly giving the null values, I can insert new rows, but the problem is that the attributes that I'm not specifying are going to contain null values. So in here, company name cannot contain null values. Let's maybe try it for the monthly payments, but I guess for monthly payments as well, it might be it might have the not null constraint, but let's try. Okay, for monthly payment as well, while we were designing this database using SQL Studio, we said for the company's monthly payment, it cannot be null as well. So for example, we could miss the last parenthesis within the query. So I'm trying to insert the new company. It says incomplete input. So this is my SQL query, and within that SQL query, I'm opening the parentheses but not closing it. But I might do the same thing in the Python code as well. So these two are giving different errors. So this time I forgot to include the parentheses of the execute function, or the other was to forget it inside the SQL query. So this is showing us that the values that replace the question marks should be tuples. So if I run it, it's going to complain that this is an unsupported type of parameter. I'm trying to give an integer, but it should be a tuple. So to correct it, I'm going to include the parentheses that surrounds the number, but that's not enough. If I just include one number, it is not treated as a tuple. I need to put the comma as well. So now it is treated as a tuple, and it's the first value of the tuple replaces the question mark. So now this is going to be an example for doing multiple things in the database or working with the database. So let's actually first run it and see what is happening here. So let me actually once again. So in here, what it does, it gives us a menu of options to interact with the database. So if I choose the first option, for example, it's going to show me the user list. If I choose the second option, so it again, after displaying the list, it shows the menu again. I can put my choice again. Let's choose 2. Now it displays all the companies in the database. For example, these are the ones that we inserted with the code, and this company 123, we insert it as a number, but a number could take the place of text as well. So let's choose the option 3. Now it is going to show users with the limit for the credit. So I'm going to insert or write the credit limit, let's say 300. Then the users that I see here, they all have credit higher than the limit. So in such programs, it is also a good idea to handle the other cases. For example, if I write 33, it says the choice should be in this range. And if I choose the option 4, it's going to not continue, let's say. So let's look at this code. So we are keeping some variable to keep the user's choice. Since we are going to display the menu multiple times, we are using a while loop here. And the condition to continue is saying that the choice should be different than 4. So for any choice that's different than 4, initially it's 0, so we are going to enter into the loop. We are going to first print the menu and then ask for the user's input. And we are converting this user input, which is a string. So anything that user types is going to be a string. But if you expect a number there, you can convert it to a form that contains number, for example, to an integer form. So in choice, now we are keeping the user's choice as an integer. Then I can have if, elif, and else structure to do something according to the user's choice. So for example, in here, if the choice is 1, what I do is to print all the users. If the choice is true, 2, then we are printing all the companies. And if the choice is 3, we need some other parameter. So we can ask for that parameter and use it in our query. So the option 4 is just printing goodbye. And since the while loop condition is for choice to be not equal to 4, if choice becomes 4, then we exit the loop. Before exiting, we just print goodbye. And for anything else, we say that, okay, the choice should be in this correct range. But one thing that could happen, I guess, if the user writes a string to this part, to this area, it is going to complain that we cannot convert a text into an integer. So that could be one more thing that we might need to be careful about. So most likely you are going to use some loop in the project. So right now we are not using the graphical user interface. We are just getting the values from the command line from as a text. We are showing text output to the user. But in the next lab, we are going to start implementing a graphical user interface. But we are still going to use Python. We are still going to use SQL-3 library. And most likely we have some sort of loop in there as well. And according to the choice of the user, or according to which window we are in, we are going to use some different functionality. And for these functions, for the things that I'm doing for choice number 1, it could be actually meaningful to use different functions. For example, I can say this is okay, choice number 1, I don't need any parameters, and this is what I do if the user's choice is 1, for example. And then I can easily replace this area by calling this function. So since we are right now doing simple things, they are not really crowded, but once we start doing more complicated things, it could become crowded easily. So it's actually a good idea to keep them as separate functions. So in this case, it would be easier to manage. And for example, you might ask one friend in your group to implement one function. So you can like manage the project in a better way if you keep the functions in a different place, for example. So now let's try to run it, but in here, since I copied it, there is some wrong indentation. And okay, let me check. Do you see what I'm doing wrong? Or is it really some weird symbol there?
I think the definition for the third choice, the form in the second line.
Oh, okay. Thank you. Okay, thank you. So it now functions as it is. The difference is that we have better way of managing the whole project, for example. And the error that I made was, thanks to a friend, this indentation was wrong. So in this example, or let's say so far, we were printing the rows as they are. So we were getting the results from the query, and for each of the rows that we get from the query, from that result set, we were printing them as they are. But most of the time we would like to actually get the individual attributes. For example, maybe on one column, or in a better way, I would like to display the names, put some space in between, then I may want to display the surname, etc. I might want to make some calculations using the integer values, for example. And to do that, we are going to get the values, or the individual attributes values, from the row. So far here, let's go to here, for example. We are executing the query. It returns us a set of results, and within that set of results, each element is called a row, and we are printing those rows as they are. But let's say for writing the users, for example, I can also access individual elements. For example, I can say, okay, get the one in index 1. So let me run it now. So if I choose the first option, now it prints the names only. So without those different elements, without the single quotation marks that we were seeing, it just prints out what we have in index number 1. So if we go back, if we are printing the whole row, I need to choose the first option. So these are, so in the index 0 I have the ID, in index 1 I have the name, we just printed the name. I can access the individual attributes as well, individual elements within those tuples. So let me come back to here. We can also, instead of using a loop, we can just execute the query and fetch one result. It returns one result from this cursor. So remember, we are connecting to a database and we are keeping a cursor to access the database. We can execute queries. If this is an insertion query, for example, it is not going to return anything. But if it is a selection query, then we can display results. We can display results using an iterator, or we can, after executing the query, we can fetch one result. It is going to return just one row. So this is equivalent to the individual rows in our for loop, but in this place we called it R. this is going to print that one row only. We can look at how many attributes there are in this row. We can also get individual elements. We just saw how to get individual elements, and these indexes are according to the selection order we have. So for example, if I just need the name, then I can just select the name. Then in this case, there is only going to be one attribute in my result, in my rows. So the length is going to be 1 if my query is like this. But if I'm projecting everything, then it's going to be the number of attributes in the user table, and indexes are in the order that appear in the database. And with these values, for example, if it is numeric value, I can directly use it in some calculation. So I don't really need to convert it into an integer value. It's already an integer. For example, in this case, this is the credit of the user. Since it's an integer, I can directly use it in some calculation and then print the value. And remember, we executed the query once, and each time I call fetch1 function, it's going to return me the next row. So the first time I call fetch1, it's going to be for the first row of the result set. Second time I call, it's going to be the second row. So the next row at the top of my result set, let's say, I'm getting the value out of there, and each time I call the same function, it returns the next one, next row. In here we are displaying the name and the date of birth of that user. So with SQL queries, we can calculate numeric values. For example, I can find the maximum credits, I can find the average credits. But if the operation is too much complicated, so normally we keep the database online in a server, and that database runs the queries and returns the results to the users on different computers through a network. And if the operation for the calculation is too complicated, we could also prefer to make the operation on the user's computer. So in user's computer, we send a query to the database on the server. So that's the normal way of doing things. But in the project, we are going to use local databases and with local files. But in the normal case, we send the SQL query to a database in a server in some other place, and it returns us the results. We can define complicated queries that are making very heavy calculations. In this case, it is not, but to give an example, we can, instead of making the calculation on the server, so as not to put some weight on the server, we can just get the entries from the server, the required ones, and make this heavy calculation on user's computer. So in here we are actually trying to do something like that. So we would like to, let's say, find the average credit, which is not a heavy operation. But to give an example, let's find the average credits using Python code. And to do that, we need the user's credits, and we also need the number of users. And while going with a loop, we are going to calculate how many users we have as well. But we also would like to keep a list of users. That's not for the calculation, that's going to be for something else. But let's say we would like to keep the names of the users at some parts. So let's first focus on the average calculation. So we have total initialized to 0, user count initialized to 0, and our SQL query is getting the name and credit from the user table. And for each row there, the first index is the name of that user. So we would like to keep a list of names of the users. So we store that name here. We also need the credits. So credit is in the second column it's going to be index number 1 for this row. We are adding it directly to the total since this is a numeric value. We can do that directly. And we increment the user count. After the for loop, we find the average as total divided by the user count, and we display some information about the user count, about this average. And remember, since we are using numeric values, the average is going to be like, so let me actually run it first. So these are for the initial ones. So we were printing one row, right? We were using the fetch one function and printing that row, and that row appears like this. We are projecting everything from the user table, and since we fetch one row, it is going to print that row. The attribute count for this row is 7, so we have 7 values in a tuple, and the index 2 of this tuple is Ramirez. It contains the surname of this user. So we get the credits, we multiply it by 2 to show that we can do calculations on these numeric values, and we get another value. So we fetch another row, and it is going to be for different users. So using the fetch one function, we can get all the rows that are in the result set of that query. So then we make the calculation and show the information. So there are 21 users. So this is total number of credits, and this average is this number. And it's not that looking good because we have like lots of integers next to the points. So to format it to look better, so there are actually in Python there are lots of different ways to format the numbers, but this is one way of doing it. As a string, we give the format. So this is saying that okay, I can have any number of decimals before the points, and after the points I can have 3 values. So the value that we would like to format is this average. So there is this average variable. We are formatting the average variable using this format. So that's again one thing. If you are working with numbers, you can use such formatting. So it is going to display 3 digits after the point. And remember, we also kept the usernames as a list, as a separate list. For example, we could run a query, get lots of attributes, and among those we might need to store some of them for some reason. For example, in this case we kept the list of users. We created an empty list at the beginning, and for each row we just append the 0th index, which is going to be the user's name. And if I print this list, it is going to be this one. So it's showing the names of all the users. So now we have an example for filtering or searching. And let me actually also remind you that so you are given functional requirements for the project. So far there is no need to do anything for the functional requirements, but for the implementation stage 2 and the final demo, you are going to implement these scenarios. And these scenarios, if you look at them, they are similar to the actions that we are doing. For example, they mostly start with saying login as some user. So for login part, we are going to talk about it in the upcoming labs. But for example, list all tributes that are assigned to this mentor. List existing addresses of this customer. Or for example, list crime scenes that this field officer is assigned to. We are actually trying to run some query and get some results and display some results. For example, if we are listing the crime scenes, we need some information to define that crime scene. The attributes of the crime scene should be displayed to the user. And we have also some conditions. For example, in here, list the scenes that's assigned to the field officer, this field officer. Which field officer? We are logging as a field officer. So we are putting our information about this user, and using that information we would like to actually run some query and display the results. So most of the time actually we would like to keep some information about the user. So in this cell what we have done was to keep all the users as a list, but most of the time after login you might want to store some information or the primary key of the user as a variable, as a Python variable. And if you need to, for example, run some query and get some results about that specific user, you can use it as a tuple that is going to replace a question mark in your query. And in this one we are giving an example for filtering or searching. So searching is actually in some of the scenarios there are, it is going to say filter, for example, filter attributes by game, name, status, and district. So for example, filtering by some attribute could mean that, okay, I input some game number, some name, and I would like to see only the ones that contain this name, for example. You can use exact matches, or you can search within the text, for example. And in this cell now we have an example to search for the partial text. So the user is going to input some string, or let's say substring, because this string is going to be contained in some position of the user's name or user's surname. And remember, we had this keyword saying like. So if I write like, I was able to use this special marks. So a % sign means this should be replaced, this can be replaced by any number of any characters. And we had this underscore, meaning that it can be replaced by just one character. And in here what we are doing is we append this % sign before and after the string that user enters. So with the input function we get some text input from the user, and we append the % sign before and after that string. And since we need to again keep a list of users, maybe we are going to do some operation about them, we are going to keep a user list in Python. So we are going to execute this query, and this query we get the ID, name, and surname from the user table, and the conditions are saying that, okay, the name should be like question mark or surname should be like question mark. So the substring can be in the name or it can be in the surname. And the substring by itself is a string. So we got some string from the user, we append the % signs before and after that string. So at some position, if I were to print this partial text, it is a string. So I can just directly replace it in my query. So we don't really need to put some single quotations here. So that's what I'm trying to mean. If I write it like this, it's going to give an error because the question mark, the thing that I replaced the question mark, is already a string. So for these two question marks, they are going to be replaced by the same thing, but I should give them as a tuple. So they are contained in this parentheses, but I repeat partial text twice. So both of them should be replaced by this partial text. Then, if there are such users, so again, I'm going through this loop. I'm appending each row, and to append each row, you can actually just directly append the row as well. But for the sake of example, I'm appending them individual by their individual values. So I'm forming some new tuple here, or some new list here, let's say. So I'm forming a new list, and in that list I have 3 items, and those 3 items are the ID, name and surname that are in each row. And if there are such users, so if there are no such users, if I look at the else part, I'm going to print no such user, because while filtering, maybe I put some name that doesn't exist, there could be no such users, and I'm going to not print anything and display the message saying that there are no such users. But if the length of the users, this list, is greater than 0, then it means that we found some users. Then what we do is to give a list of users. But while giving the list of users, let's say I don't want to display the ID of the users. Let's say in a different scenario, these could be the social security numbers of the users. And to search a user, I don't want to display the social security number of those users to the people. Instead, I would like to assign some other numeric value to each user, because then I'm going to ask for the user to, actually I'm talking about 2 different users. So the user here is a table, and somebody is going to use our database as well, use this Python function. The second user that I'm talking about is that person. So let me call that a person then. So a person is going to use this database, and we are going to show such users to that person, and that person is going to choose one of those users to show the companies that this user is a partner of. So in this code we are trying to do that. But first we search some user. If we have length greater than 0, we would like to display those users, but while displaying, we are assigning some new indexes to each of these users. So those indexes are actually the order they appear in the users list. So we kept a Python list, and in this list we are going to get each of these users, and for each user in this list I am showing this index value that I'm incrementing, so that they are starting from 1, not from 0 this time, but the loop is from here, right? So for the loop I'm getting each value, each element in the users list, and they are called the user here. And for the user I'm showing the name. The name is in index 1 and the surname is in index 2. The ID of this user is in index 0. I'm not displaying it to the person that uses this database, but I'm going to use this ID in the next stage. So then after showing all the users, then we are saying, okay, choose one user to show more info. Then if the chosen index is a valid index, because again user, the person could enter some value that's not in range, so in here we make that range check. So while printing we started from index 1, we incremented the indexes, and at the end index is going to be equal to the number of users. So if it is like greater than that index value, that's an invalid value, or the chosen index should be also greater than 1. We don't allow negative values. Then we would like to use this chosen index to find the ID of the user. So the ID of the user is, for a row, it's in the index 0. But which user? So we have actually multiple users, right? In the users list we had multiple users, and the user chose the user, the person chose the user through an indexing that starts from 1. But in Python lists, the first element is index 0. So because of that, I should say chosen -1. So it is going to be the row for a user, and within that row I'm getting the ID value. So user ID is here. Social security number, for example, is in the user ID, but I'm not displaying it to the person directly, for example. Then let's say for this more information part, we are going to project everything from the user table for a user where ID is equal to this question mark that is replaced by the user ID. So I'm using this user ID to find the corresponding user. This time there should only be one user because we are using the primary key. So to find some, or let's say if I'm storing the users as a list, if I'm going to give some choice to the person, and if that person chooses some user, if I would like to display more information about that user, I need to keep the primary key. So to access some individual row, the best way is to have the primary key. So we can have some sort of searching, for example, with name and surname, but it's not guaranteed to find an individual row. It may find nothing, it could find more than one values, more than one entries, but the best way to find one individual entry is through the primary key. And if the primary key is a composite one, I need to keep multiple things. But then after executing this query, I know that there is going to be only one user with this specific ID. Therefore, I'm just using the fetch one function. I don't really need to have a loop there. I'm printing the values for this user. And let's say I would like to also print the partner companies of this user. Then again, using this user ID, the same user ID, I can have a more complicated function, I can have a more complicated SQL query. And in this query, what we are doing is to join the partner of and company tables. We would like to show the company ID, company name, and the monthly payments for the companies that this user is a partner of. And this else part is for the person choosing a wrong index for the users. So actually, let me run this. So it asks me to enter a substring, maybe let's say U. So these are the users that contain a U in their name. And among them, so we are listing these users through these new index values starting from 1. So I'm not showing the ID of that user, but I'm going to choose it through this indexing. For example, I can say 3 here. And we are now giving more information about this user and then the partner companies of that user, for example. Let's run it again. So for example, I can look for a longer text, NE. So these are the users that contain the letters NE in either their surname or their name. So Wayne contains it in the name, for Green is in the surname. And among these users, I can choose one and display more information about that user. And actually, while the program is running, if I insert a cell below here, if I try to print the user ID, I will see that it is the user ID for this last option. So remember, in here displaying Wayne, we have number 1. But when we show the full detail, we see that Wayne's ID is 4. And Wayne's ID, this user ID, is kept throughout the program. So while the kernel is running, among these different cells, I can use this variable in some place. So I can, like, for example, have the loop to print the companies in some other cell. So the thing is here, it says cannot operate on a closed database. So that's one thing that you might encounter if you try to copy it, paste it from some of the cells. We need to keep the connection onto the database. For example, most of the cells, after creating a connection to a database, they are going to close the database as well. They are going to close the connection. So if you need to use it in some other cell, these two things are what you need. So if I just copy and paste the printing part here, I need to connect it to the correct database, and I need to keep a cursor to that database. Now we can print the companies. So the thing that about closing is, if you don't close the connection to that database, if this Jupyter Notebook file is open, and if you are, for example, trying to delete or move that file, so if it is in use, if it is still connected, then you may not copy it or move it. So that's why we actually close the connection to the database. But if we just interrupt or stop this kernel, then it is also going to close the connection actually. And in some databases, for example, you might put some conditions about how many users can connect this database, etc. So closing is something we do at the end, and if we are changing some values, we should commit as well. So those are two things that we can remind. Any questions, problems? So in this lab we actually made a start in Python, and in the final demo for your topic, each of these scenarios, so all three of them, should be available through a user interface, through a graphical user interface. So we have seen some functions to execute queries, get results, and get some input from the user. And in the next labs, in the upcoming ones, we are going to see how to use a graphical interface. So we are going to have some windows, and to do that we are going to use the PySimple GUI library. So if you don't have any questions, that's it for this lab. Maybe one more thing is, in here you can also download this Jupyter Notebook as a different file. So if you are going to use a different version, if you are not going to use the Jupyter Notebook, I can also include the Python versions. So I can convert it to Python and put it there. But one thing about it, it's going to contain all the code. So remember, in the other parts we had cells, and in here there are no cells. It's a complete Python file, and it might give some errors. These are not designed to run as a whole. So that's just one thing. So if you don't have any questions, that's it for today. See you later.